Hi, this is Manoj Yadav and you are watching Mechanotherapy. So today we are going to discuss about IC engines. So when we talk about IC engines, we must know what actual engine is. So engine may be defined as a machine that converts the chemical energy of fuel into heat energy and then into mechanical work. So you must have seen in the engines what happens in the engine. We use the fuel, that is either diesel or petrol. Now these fuels have the chemical energy. Now when they get burned, they produce heat energy, and then this heat energy is converted into the mechanical power. So that's why we can define an engine as a machine that converts the chemical energy of fuel into heat energy and then into mechanical energy. You can see in the diagram there is a schematic diagram of engine. We have a source and a sink. Source may be defined as a body from which whatever quantity of heat may be distracted, but its temperature doesn't change. Similarly, sink is the body in which however temperature may be given, its temperature doesn't change. Now suppose source is having temperature T1 and sink is having temperature T2. Now from source the heat is given to the engine. Suppose Q1 heat is given to the engine. Now we know that total heat given cannot be converted into work. Some of the heat gets waste. Now this waste heat is given to the sink, which is Q2. So finally, if we find out the efficiency of engine, we will get efficiency equal to output upon input. Here output is the work done and input is the heat supplied Q1. So we can define efficiency as efficiency equal to W upon Q1, or W may be defined as Q1 minus Q2. So efficiency equal to Q1 minus Q2 by Q1. Now heat is directly proportional to temperature, so we can write efficiency equal to T1 minus T2 upon T1. This is all about the efficiency of the engine. Now next is types of engines. So we have total two types of engine. One is internal combustion engine and another one is external combustion engines. The engines in which ignition of fuel occurs inside the engine cylinder, they are known as internal combustion engines. For example, all the types of vehicles, whether it is a truck or bus or bike or motor car, in each and every vehicle the fuel burns inside the engine cylinder. So these engines are known as internal combustion engines. Now another are external combustion engines. In external combustion engines, the combustion of fuel takes place outside and then heat is generated. Heat which is generated is carried out with help of a fluid to the place where it is to be used. The simple example of external combustion engines is steam engine. Now in steam engines the steam is produced in boilers at some other place. Now that heat or that steam is given to the place where the turbine is kept, and then it works on the turbines and the power is produced. So these engines are known as external combustion engines. Here we will discuss only the internal combustion engines. Now internal combustion engines are of two types. One is SI engine, that is spark ignition engine, and another one is compression ignition engine or CI engines. In SI engine or spark ignition engines, combustion of fuel occurs due to the spark plug. So generally the petrol engines are known as the spark ignition engines. In compression ignition engines or diesel engines, the combustion of fuel occurs due to the high compression of air to high temperature and pressure. So we can classify internal combustion engines into these two types, SI engines and CI engines. Now you can see the diagram which shows the construction of an IC engine. You can see the main parts of an IC engine are inlet and exhaust valve, spark plug, cylinder head, piston, piston rings, connecting rod, crankshaft, crankcase. So all these are the various parts of a engine. We will discuss these parts one by one. So first of all, we will discuss cylinder and cylinder head. Now cylinder is the main body of the engine where combustion occurs. It is a stationary component which is made up of cast iron. It is made up of cast iron to bear the high temperature and pressure inside the engine cylinder. Now piston reciprocates in the cylinder. Cylinder head is the topmost part of cylinder, and this cylinder head provides space to inlet valve, exhaust valve or spark plug. So these three things are placed on the uppermost part of cylinder, which is called cylinder head. Okay. Now second part is piston and piston rings. Very important part of engine. Piston, it confines the gases in combustion space and transmit the full force of burnt gases to the connecting rod and crank. Now piston is generally made up of aluminium to provide the high speed of the vehicles. Piston has two types of rings. One are known as upper piston rings and another one are known as lower piston rings. The upper piston rings prevent the leakage of gases, while lower piston rings prevent the leakage of oil into the cylinder head. Now third part is connecting rod. Connecting rod acts as a linkage between piston and crank. It transmits the force of piston to the crank, causing it to turn and convert reciprocating motion of piston to rotary motion. Now this connecting rod is generally of I section, ensuring the minimum weight. Its upper part is connected to the piston with a pin which is known as gudgeon pin, and its lower part is connected to the crank with a crank pin. Then we have crank and crankshaft. Crank gets force to rotate by piston via connecting rod. So we can say that crank do the rotary motion. Now crankshaft is used to transmit the power. Crank and crankshaft both are made of smoothly finished steel forgings. Crankshaft mounts in bearings and can rotate freely. That is, it is placed in bearings and it can rotate freely. Now the fifth and very important part is crankcase. So cylinder, piston and crankshaft, all these three are placed in a crankcase. Crankcase is a type of covering which covers all these accessories. So crankcase serves as an oil sump also for the storage of lubricating oil. It is generally made up of cast iron. The sixth part is camshaft and valve mechanism. The opening and closing of inlet valve and exhaust valve occurs with help of a shaft which is known as camshaft. On these camshafts, cams are fitted which continuously move with help of motor. Now camshaft operates the inlet and exhaust valves with help of cam, follower and rocker arm. You can see the diagram of a camshaft which is having the cams on it, and they are pressing the inlet and exhaust valves. Now seventh and very important part is flywheel. A flywheel is a heavy balanced disc fitted onto the end of crankshaft. It is fitted at the end of the crankshaft. Now it stores excess energy during the power stroke. Whenever the burning occurs in the engine, at that time we have the maximum power created or generated. This excess power is stored in the flywheel. Now this flywheel provides energy for auxiliary strokes when power is not generated or the engine is requiring power, then it provides the power. So it reduces the cyclic vibrations and maintains the uniform speed of the vehicle. Generally the flywheel is also made of cast iron. Now the last part of the engine is governor. A governor is a device which is used to measure and regulate the speed of an engine. You must have seen in some buses where speed is limited to 60 or 80 km per hour. So as the vehicle approaches that speed, the fuel supply is automatically cut off, and in this way they maintain a certain limit of speed. So speed is maintained within a certain limit by controlling the supply of the fuel. So guys, this is all about the construction of IC engines. In our next lecture we will discuss about the working of 4-stroke petrol engine. Till then, thank you everyone.